As the device runs, the Arduino code initializes all components before entering the main function. A valid left to right or right to left gesture sets the start, telling the forward movement to begin for a 5-minute cleaning cycle. During operation, the IR distance sensor continuously samples data for the distance from the edge, converting the raw ADC value into voltages that can be interpreted. When the sensors cross the voltage threshold, a short 90-degree maneuver is performed to ensure the device continues to cover surface area on the desk. A timer also triggers the LED flash at the 2-minute mark to signal the end of cleaning.
The housing of the device was designed to enclose the circuit inside with cuts so the gesture sensor and LED are accessible to the user. The top is also easily removable by simply unscrewing the bolts which fasten it. After unscrewing this, a compartment which stores the rice from the vacuum can be easily located and removed. We designed this compartment to have small holes to let air from the vacuum through but keep the rice inside, along with replaceable, double-sided tape to trap rice. The flooring was cut so the vacuum could be low to the ground. We found that it performed best no more than 10 millimeters high. We also added a 3D printed sensor holder which allowed the device to find the edges of the table based on a slight downward pointing angle.
As for the circuit elements of our Deskinator, we have 2 infrared sensors, a gesture sensor, 2 DC motors, a motor driver, and a 12-volt DC fan. We use 2 9-volt batteries in parallel to power the Arduino, as this provided more current to our components, and we connected everything except the fan to the pins of our Arduino, allowing us to control these components through voltage signals from our code, which runs when motion is detected from our gesture sensor. Our fan, though, required a larger voltage than the 5 volts from the Arduino, and therefore we used a MOSFET circuit to control an external 9-volt battery to power the fan, which was activated by the pin of the Arduino.
With regard to the code, we first initialize all of the output devices in the Deskinator. This includes the gesture sensor, the 2 TT motors, 2 infrared distance sensors, and an LED. To begin, the device requires a left to right wave above the gesture sensor, which is detected by its 4 IR photodiodes. This starts the robot and begins a time variable. As for the distance sensors, their analog value is first converted to voltage and then used to determine the distance read. In terms of basic movement, the code initializes the robot to be moving towards the right, continuing along this path until either infrared sensor reads a distance greater than 20 centimeters. Once an edge has been detected, it is programmed to first turn towards the right, move the same distance as the robot's length, and then turn right again to enter a new path on the table. Upon doing so, the direction variable is adjusted to indicate it now moving in the left direction. The time variable is analyzed in the background and will cease the process once a 5-minute value is reached and indicate this by flashing the LED.